At this point, I want to invite a special guest on stage. Most of you know Eric as the CEO of Google. I've worked with Eric for over 6 years now. In all the meetings I've had with him, I've known him first and foremost as a computer scientist and a deep technologist who has pioneered a lot of the work in cloud computing we are talking about here. Every time we talk about, he wants to talk about the web platform, where it is going, what the next set of evolutions are, and so I'm very excited to have him here to share a few words with us.
Sundar. Thank you. Thanks, everybody. My congratulations to Sundar, Linus, and the whole team. It's obviously an amazing set of product announcements. We're really part of a journey of cloud computing. And this journey can be seen both in a historical context in terms of also what we think is going to happen in the next many decades, that cloud computing will sort of essentially define computing as we all know it. I work at Google primarily because Google is one of a handful of companies that can do real computer science at scale, and that we are able to actually build platforms of the kind of complexity that the simplicity that you've seen now can generate. In other words, these complex systems, when properly built, produce these extraordinarily elegant and simple solutions. Now, why is this so hard? Okay, well, I probably have as good a story as any. In 1983, I was part of a team at Sun that was very proud to announce the 3 M machines. The M's were 1 megapixel, 1 megahertz, and 1 megabit. Right? Do the math, guys. And as part of that, we introduced a diskless computer because disks in your client were such a problem. So this is not a new concept. Don't be confused. There are very few new ideas in computer science. The last really new one, by the way, was public key encryption in 1975. Somehow we're always bringing them back because we want to either we love them or because they were right and we couldn't implement them. So why is this one so difficult? Well, we did that for a while. We had all the IT stuff. Then the web was invented. And the web is not really cloud computing. The web is really an information resource of enormous impact. We all understand what the web has done to society, to our industry, to all of us as individuals, and we'll forever be grateful to Tim Berners-Lee and the team that made that happen. And in fact, in the first cycle here in 1995, remember the Netscape IPO, the Java announcement and all that, ultimately leading in 1997 to an announcement by Oracle and myself and a whole bunch of other people who were heavily involved of a product called the network computer. Exactly what we're talking about today. Read the language. Use your favorite search engine and look at what I said. Right? So why did it fail? Right? Why should you believe us now? Well, we were right then and we were wrong then. We were right that the underlying problems that computing had evolved, the client server, the complexity, the costs, and so forth, really were a problem, right? But we were wrong in understanding how complex and subtle the problems were. And of course, we were in the middle of the bubble, and God knows however else we were distracted, and so forth and so on. It was all sort of an amazing time. But when I think back hard, it was because we couldn't build great applications on the web technologies of the time. We could build information resources. You could read things and do things and so forth. But you couldn't build web applications that were at the scale and power of the then existing desktop applications, which at the time were Olay and Win32 and various Mac APIs and so forth and so on. So what did it take? Well, first thing is it took time. Moore's law is a factor of 1,000 in 15 years. So 13 years ago, 15 years ago versus today, you have 1,000 times faster networks, CPUs, screens, just literally more horsepower at the networking and disk level. The disks are that much faster. The network is more reliable and so forth and so on. There was a technology built in 2003, 2004, which it was called asynchronous JavaScript and XML, abbreviated as AJAX, which built the first interesting web apps. Gmail, for example, was either the first or one of the early first AJAX applications. And all of a sudden people said, this web thing is actually kind of useful. I can write some pretty interesting applications. They can update themselves and so forth and so on. And then a general technology now known as LAMP, which stands for Linux, Apache, MySQL, PHP, Perl, and Python, and various other Ps, evolved as a platform for the back end. So all of a sudden you had a client and you had a back end that were powerful enough that a new programming model, which is indeed what these things are built around, where people, instead of building these large monolithic pieces of programs, they would take snippets of code, objects if you will, and they would aggregate them together in languages like Java and JavaScript, which sort of then came to dominate the middle period. Now, why am I telling you all of this? Because it took us all of this work to get to the point where a modern browser could emerge in the form of Chrome. Chrome, of course, now is a huge success that we've highlighted. Was also interesting. When Larry and Sergey, of course, Larry and Sergey have always been ahead of me on these things. When I first joined the company, Larry and Sergey absolutely wanted to be in the browser business and the operating system business, and I absolutely was not interested in being in either, and I said no. And I worked very, very hard. They sneakily hired a number of people who were very, very clever to work on the Firefox browser, which we helped fund through an advertising deal, which has been amazingly successful. And ultimately, that core team ultimately was able to build this phenomenal browser called Chrome, which finally broke through the architectural frameworks that people had with respect to security and speed, which we've highlighted so now. We've gone from a point where we had reliable disks and unreliable networks to a world where we have reliable networks and the absence of a disk or an unreliable disk, or we don't really care about the disk. Architecturally, that's a huge change for the way people think about applications. And what I like in particular about this is that you have a series now, you have this sort of the whole industry working on a set of platforms that set up, in my view, real success going forward. Let's review. The first is the adoption of HTML5. If you haven't heard enough about HTML5 this morning, go spend some more time reading about it. It is now finally possible to build the powerful apps that you take it for granted on a PC or a Macintosh with the graphics and so forth and so on. It's finally possible to build them on top of a browser platform. And we show them over and over and over again. Furthermore, every vendor in the industry, Google and of course all of our competitors and everybody else, has announced an HTML5 strategy. So it's not just us. And it really is a standard. Even Microsoft has announced its success, which is always exciting. With Chrome OS, we have the development of a viable third choice in real operating systems in the desktop. There's just not been an alternative that took advantage of cloud computing, and now we finally have a product which is strong enough, technical enough, scalable enough, and fast enough that you can build actual powerful platforms on it. It's different. It's not the same, and it's different in ways that matter if you believe in cloud computing. And of course, you also have solutions like Citrix to help you deal with legacy architectures, existing IT architectures, and all of that. So my message here, when I want you to think about this, is think of this as a journey. Think of this as something that we've been talking about for a very, very long time, right? That our instincts were right 10 years ago or 20 years ago, but we didn't have the tools of technology. And that in my view, and I hope when you get our product that we're going to send you as soon as we can, when you play with it and hopefully use it every day, as many people at Google are, you'll realize it does in fact work. You really can build everything that you used to have to sort of mix and match and so forth and take advantage. Why do I think this strategy is going to work well? A lot because of mobile computing. The existing architectures at the IT level and so forth really weren't built for the kind of uses and interaction and interchange that goes on among mobile apps and the new platforms. So I think there's every reason to believe that when you go back and you look in history, not only is this the right time to build these products, but because they work and they work at scale, they'll be very, very successful. So again, thank you so much. I know you've been here all morning, and I hope you enjoy the rest of the show. Take care. Thanks. Thanks, Sundar.
Thanks, Eric. I've been personally on this journey of cloud computing for a while, but it's very clear Eric has been at this longer than most of us in this room. So great to hear from him. So let's recap as to what all we talked about. So we announced our user base of Chrome, seen tremendous adoption. We've grown 300% this year. We are at 120 million active users, a very conservative count. We have a whole slew of features coming up in Chrome focused on speed, with Chrome Instant being very exciting. All those features will be rolling out in the next few weeks. Chrome Web Store, which was the second thing we talked about, is ready to use today. You can go to google.com/Chrome Web Store, install apps. It'll be rolling out later today. And finally, the Chrome OS pilot program. We will be shipping these devices to users who apply and are eligible for the pilot program, including all of you in this room. And hopefully you get a chance to use it, try it out, and enjoy what nothing but the web looks like. Thank you.